Hello students, how are you? Hope you are doing well, and today our topic is in equilibrium, and it is the last topic of our chapter, telling effect of the forces, and its definition is a body is said to be in equilibrium if no net force acts on it. If there is no net force acting on a body, then body is in equilibrium. Or there is another definition of it: if number of forces acting on a body such that their resultant is zero. Remember that the resultant of forces is zero. Then if body is at rest, it will remain at rest. In equilibrium we have two conditions. If body is at rest, it will remain at rest. Then we say that the body is in equilibrium. And if body is in motion, then it continue its motion with uniform velocity. This state is known as equilibrium. Okay, let me discuss them one by one. First, we have the two conditions for the equilibrium. Firstly, we discuss the first condition for the equilibrium. A body is said to satisfy first condition for equilibrium if the resultant of all forces acting on it is zero. Just remember that resultant of all forces, if we have, let's suppose we have two forces here, F1 and F2 forces, both are of 50 Newton, but they are in opposite direction. They cancel the effect of each other and the picture hanged, and you see that picture is hanged on the wall and it is in equilibrium, it is at rest. Okay, the picture is not moving. If you see in your room, you find many pictures and many things which are hanged on the wall. Why they are not moving? Because they are in equilibrium, and the all forces acting on it, their resultant is zero. Okay, let's suppose on the picture we have n forces, F1, F2, F3 up to Fn. We have up to from F1 to Fn forces on a body, acting on a body. Then their sum is equals to 0. Or you can also use this sign. This is sign of summation or sigma, which is equals to 0. Sum of all forces, summation, F equals to 0, and the symbol is a Greek letter called sigma, and used for summation. Used for summation means sum of all the forces, sum of all the values up to n. Equation 4.9, this equation is called first equation of equilibrium, in which sum of all forces equals to 0. First condition for equilibrium can also be stated. We have, as you know that in everything we have x, y, z plane. So we can distribute the forces in its x, y and z components. Let's suppose we have in x component F1x, F2x, F3x, F up to Fnx equals to 0. So on x axis the forces up to n acting all are 0, then summation Fx equals to 0. For y component, all y component forces like F1y, F2y, F3y up to Fny equals to 0. So sum of all y axis component forces equals to 0. And for z component we have forces F1 z, F2 z, F3 z, F up to Fn z, which is equals to 0. So summation of all z axis forces equals to 0. So these are the terms used in the form of x, y and z components. Okay students, we have different examples of the equilibrium. First condition of equilibrium. First is the book laying on the table. If a book laying on the table, it is said to that all the forces acting on the book is 0 and the book is in equilibrium condition. I already told you a picture hanged on a wall are at rest, thus satisfy first condition of equilibrium. I already told you about it. If all forces acting on the picture which is hanging on the wall is 0, then it satisfies the first condition of equilibrium. Or a paratrooper coming down with terminal velocity. Terminal velocity is constant velocity. Always also satisfy first condition of equilibrium. You can see here in the picture the paratroopers are coming down with terminal velocity, and they are also in equilibrium. They satisfy the first condition of equilibrium. Now, point to be noted that linear acceleration, what is it? In first condition of equilibrium, when first condition of equilibrium is satisfied, then there is no linear acceleration produced in a body. Linear acceleration is straight line acceleration. Okay, when first condition of equilibrium is satisfied, there is no linear acceleration produced in the body. Second condition of equilibrium is if number of forces acting on a body so that total sum of torque, here in first condition of equilibrium we have total sum of forces, but in second condition of equilibrium we have total sum of torque of all the forces is equals to 0. Sum of torque of all the forces equals to 0. This is the second condition of the equilibrium. Now we consider the two bodies here. Now let's discuss first one firstly. You can see here two forces which are equal and opposite to each other, and if you pull a box with equal force, two students are standing and they are pushing the table toward themselves. One is pushing toward this side and one is pushing the table toward this side, and both are pushing the table in opposite direction with the same forces. So what happened? There is no change in the position of the table because both students are applying the same forces. So here in this case the forces are equal and opposite to each other. Both are acting along the same line, hence their resultant will be 0. So according to first condition, the body will be equilibrium. Now okay, according to first condition, you can see here the body will be in equilibrium. Now shift the location of forces. One is here and one is here. Okay, now the body is not in equilibrium, although the first condition for equilibrium is still satisfied. Here you can see that if you change the position of the forces, what happened? If you move the body start rotating. Then if one force is here and one is there, so couple is produced and body start rotating, and this is no more, it will not no more remain in equilibrium. So it is because the body has tendency to rotate. The situation demands another condition for equilibrium in addition to the first condition of equilibrium. So in this situation, we have the first condition of equilibrium, but there is something else which is used here. So this situation demands another condition for equilibrium in addition to the first condition of equilibrium. So that condition of equilibrium is the second condition of equilibrium. Point to be noted here is in first condition there was no linear acceleration. In second condition there is no rotational acceleration. When second condition of equilibrium is satisfied, no rotational acceleration produced in the body. So it is these are your first and second condition of equilibrium. Now we will discuss its states in the next video.